Okay, good evening, ladies and gentlemen, and welcome to day 3 of Lean Six Sigma Green Belt Hackathon. So, first, let's recap whatever we have seen yesterday. Okay, let's recover our 86%. Uh, if you remember 86%, or that also has been forgotten. Okay, so chalo, let's recover randomly, put the topics in the chat what we discussed yesterday so that we can start from there. So let's open your notes and put it in the chat. What did we discuss? Yes, very good. Operational definition, then measurement system analysis. Very good. Then what? So first we recapped about the day one, then we started this, right? And 8614, perfect. Yes. So 8614 also we discussed yesterday, which is 86% we forget and 14% we remember, right? Yeah, टाइप्स ऑफ डेटा वगैरह कल देखा था क्या? टाइप्स ऑफ डेटा कल देखा था, परसों देखा था, आई डोंट नो. Yes, hypothesis testing, very good. Null hypothesis, alternate hypothesis, p value, p low, null go, right? So we saw that Minitab exercise as well. Process capability analysis, very good. So yesterday we saw histogram, box plot, statistical data, right? Where mean, mode, median, first quartile, second quartile, third quartile, right? So all those things, box plot we have seen, SNC we have seen, stability, normality, capability, control chart, right? The X bar, UCL and LCL, upper control and lower control limit, operational definition, measurement system analysis, MSA, gauge R&R and AAA, attribute agreement analysis, as well as GRR. So GRR value should be less than 10% perfect, between 1 to 10 to 30 it's acceptable, above 30 you have to reject that. Okay, then it comes to AAA, there is a kappa value that it goes the same way, 1 to 0.9 it is acceptable, 0.9 to 0.7 sorry 1 to 0.9 it is best, 0.9 to 0.7 it is acceptable, 0.7 above you can 0.7 below you can reject it. Okay, yes, 2 sample t-test we yesterday we saw, and the advanced level, as I mentioned to you, we will discuss that in the in the next level, which is the black belt level. So next week we have the black belt hackathon where we will discuss all that stuff. Okay, now let's go to the next level, which was pending yesterday's topic. The topic is regression. Okay, now when do we use regression? Whenever we have two continuous data variables. Okay, when we want to see the relationship between two data points, then you can do the regression analysis. Okay, so regression basically starts from scatter plot. Okay, so scatter plot shows correlation. Graph, basically it's the name of the graph, but the correlation is nothing but y, that's it. Okay, correlation meaning establishing relationship between x and y, that is called correlation. What is regression? Regression is predicting the value of one variable on the basis of another variable. Okay, so we will discuss both these aspects with the help of Minitab software itself. Okay, with the help of the Minitab what you can say exercises. Okay, so we'll understand that. Now, what is correlation? There are 3 types of correlation generally. Okay, when do we use correlation? Example, let's say my study time and my marks in the examination. Okay, so if I study more, let's say 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, etc. More I study, more, let's say, more I will get the marks. Generally, this will be the pattern, and this is called as positive correlation. So my study time is my x, and my marks is my y. Y is my output. So more I study, more will be my marks. This is called as a positive relationship. Now the same can be brought into Facebook time or Instagram time and my marks. More time on Instagram, less marks I will score, because I will study less, right? So if I draw that, so it is 1 hour, 2 hour, 3 hour, 4 hour, 5 hours, 6 hours, etc. Less the time, more marks will be there. Okay, as I am increasing time on Facebook and Instagram, my graph of the mark will go down, and it is called as negative correlation. As my x increasing, my y is decreasing. It's a negative correlation. Okay, and there is something called as no correlation as well. Let's say my attendance in my classroom has got, meaning only if I attend without giving focus and study, that may not serve the purpose. Okay, you can have 100% attending student with very less marks. You have less attendance student but having good marks, because it is all about how much time, how much is the way you are studying, right? So attendance and marks, if I collect the data, I will get similar kind of no pattern. So it is called as no correlation. These are the three basic correlations we see in our processes: positive, negative, or no correlation. Are you clear, everybody? Just give me yes in the chat box. We will do one exercise here, one Minitab exercise, so that will give us this understanding. Okay, just download this example. Download this example, this Minitab file, and open that quickly, and let me also do that quickly. The name of the file is scatter plot. So this graph which we are going to plot on Minitab, this graph is called as scatter plot. Okay, yeah, once it is open, let me know in the chat. The graph is open. Done. Yes, guys, I'm waiting for your confirmation. Done? Open? हाँ, तो बताइए मुझे, तभी मुझे समझेगा. Very, thank you very much. चलो, confirmation आ गया है बहुत सारे लोगों का. All right. So here we have a data of the annual profit of the company and expenses in learning and development. Okay, now this expenses in lakhs of rupees and annual profit in crores of rupees. Okay, for example, in the first year, this company spent 35 lakhs in learning and development, skill development vagara, technical skills and soft skills, etc. And then the profit they have got is 4 crore rupees. The second year, they spent 20 lakh rupees as learning and development. That year, their profit was around 2 crore rupees. Okay, so here X is learning and development expenses, and our output Y is our annual profit. Okay, so first we will make our scatter plot. So if you click on graph, the first option is scatter plot. Just click on that, graph and scatter plot. All right. Okay. Super. Chalo. So then click on OK. In the Y, you select profit, and in X, you select expense on L&D, learning and development. Okay. Done. and just click on OK, and you will get this graph. Got it, everybody? Just give me quick yes in the chat box. Everybody got this graph? Now tell me, is it positive relationship, negative relationship, no relationship? Any pattern you're observing here? Any pattern? Just observe this. No relationship. No relationship. Okay. So you can see here, when my L&D expense is 20 lakhs, my profit is 2 crore. When it is 24 lakhs, it is 3 crore. When it is 35 lakhs, it is 4 crore. When it is 37 lakhs, it is 6 crore. When it is 42 lakhs, it is 7 crore. So majority of the points, if you observe, is giving you relationship like this. See, you will never get all the dots on the line, okay? There will always be variation, because variation is the nature of nature. So as of now, it shows kind of a positive relationship. Okay? So you can observe a pattern going upwards, right? As you travel from left to the right, the data is going upwards. It shows a positive trend. Are you clear? Yes? So this shows a positive correlation. Even though sometimes we may get that it is not a positive correlation. Now let's do the regression on this. Okay, so this is called as a scatter plot. Scatter plot just shows briefly about the relationship between x and y, so which briefly it's understood as a positive relationship. Let's go for regression. So go to stat, second option is regression, and in that fitted line plot. Stat regression fitted line plot. Stat regression fitted line plot. Just click on that. In the Y select profit, in the X select L&D expense, and click on OK. Now this is the same line. Just like if you remember yesterday, we discussed about the time series plot, and then we made a control chart. The same data, the chocolate weight wala data, right? The same way, first we plotted correlation, which is scatter plot, and now we have plotted regression. So scatter plot shows us whether there is a relationship. Regression gives us another 3 more information. What are the informations here? First, we get the line of best fit. This red line is called as line of best fit. Okay. Then we get this R square value, which is 76.8%. Now, if R square value is between 0 to 33%, it is low strength of the relationship. See, R square shows the strength of the relationship. Now, what is strength of the relationship? Strength of the relationship is nothing but how much your X is influencing your Y. How much percentage influence. Okay, see, that means how much close they are. How much X and Y are close to each other. In our life also, there are few friends who are very close friends. We can share everything with them, right? So in that case, R square value will be very high. So let me explain you first. 33 to 66% will be moderate R square value, and 66% and above strong correlation. So those very close friends are strong correlation zone friends. Okay. Then there are few moderate relationship friends, and there are few long relationship friends. Okay. So if the R square value is low, moderate, and strong, it depends on that. So right now it shows a very strong correlation between X and Y. Okay. Then comes the third element, which is called this equation. This is called as regression equation or prediction equation. Both are same thing. Regression or prediction equation, which shows y is equal to a plus bx. Y is equal to a plus bx. Write this down. Y is equal to a plus bx. Now in this, annual profit is y, a is this is called as intercept, b is this is called as a slope, this is intercept, and this is our x. Y is equal to a plus bx. Y is output, x is input, right? What is a? A is called as intercept. Write this down, I will explain you. And b is called as slope. Okay, let's try to understand intercept. What is intercept? Wherever, see, if I extend this line of best fit, okay, wherever it hits the y axis, this point is called as a. This point, if I extend the line of best fit, red line, wherever it bisects the y axis, this point is called as intercept A, which is this 1.8 minus 1.817. And what is slope? Slope is this 0.1883. 0.1883. Let's try to decode slope. What is slope? Now here, X is, try to understand, this is very important. X is expenses on learning and development in lakhs of rupees. So it is in lakhs. Okay. And your profit is in crores of rupees. So it is in crores, right? Now what is slope? Change in y. So write down the definition of slope. Slope is equal to change in y with 1 unit change in x. 1 unit change in x. So change in my y, which is my output, with 1 unit change in x. That means here the unit is 1 lakh rupees. Our expenses unit is 1 lakh rupees. So what it says, if I increase 1 lakh rupees L&D expenses, how much profit it is increasing? With 1 lakh rupees increase, how much profit I am getting? So here the equation says 1 lakh L&D expenses is giving you 0.1883 crore of profit. That's why it is called as slope. 0.1883. So you spend 1 lakh more, you will get 0.1883 meaning 18.83 lakh rupees. 0.1883 crore meaning 18.83 lakh rupees. So you spend 1 lakh rupees on L&D, you get 18.83 lakh rupees profit. Positive 18.8 because the slope is positive slope. You can see here plus. Are you clear? Just give me yes in the chat box. Clear everybody? Are you clear about line of best fit? What is R square value? What is the equation of regression? Everybody's clear? Okay. Now tell me. Yeah, because see the lowest value of y is 2. So because that intercept is actually going below that 2, that's why it is called as minus. If it would have intersected somewhere here, that would have been a plus 1. Okay. This would have been plus 3.7. Okay, this would have been plus 5. This would have been plus 7, plus 6, like that. Okay, that's why this is minus. Now, let's calculate with this equation. This equation is in front of you. Let's calculate. So regression equation is a prediction equation. We can predict the value of y with the help of x, or the value of x with the help of y. Now let's consider my x is 30. Let's consider this is my x, right? L&D expense is my x. Let's consider this x is equal to 30. What is my y? Calculate this quickly. What will be my y if my x is 30? Chalo, everybody just do this calculation, give me the number. So I will just decode this for you. So y is equal to minus 1.817 plus 0.1883 into 30. So do this calculation and give me the answer. So that means if I spend 30 lakh rupees in L&D expenditure, how much profit I can get out of it? Give me the answer quickly. So it is not 38 lakhs, it is 3.8 crore. It is 3.8 crore because the y-axis is in crores, not in lakhs. Okay. So here let's validate this. If I draw, now understand this. If I draw a vertical line from 30 like this, and then if I draw a exact horizontal line like this, it will come to around 3.8 crore. That's why it will be around 3.82 crore. Perfect. Absolutely right. Clear? So this way you can predict the value of x with the value of y. Okay. So this is called as a basic correlation and regression, which is covered in your green belt curriculum, and the advanced level we will discuss in the black belt in the next week. Clear everybody? Very simple. Just give me a quick yes in the chat box. Super clear hai? Where will you use this? In your process, where will you use this? Where will you use this? Which XY relationship you will use this? Type in the chat box. Quickly think about it. In your process, where is the opportunity of implementing this correlation diagram? Raw material cost and product cost. Very good. Very good. Super. You are getting minus 48.86 because first you multiply that and then you minus that. You have done the ulta. That's why it is getting minus 48.86. Okay. New equipment cost, RMC, raw material cost. Okay. Cost reduction plan. Okay. Very good. What else? What else? So can we see experience of the people and the defects? You can make a graph out of it. Experience of the people on the x-axis and the defects created on the y-axis, just to see whether there is a relationship in x and y. Okay, so you can play around this just to check. Okay, what is, so do not assume anything. See, analysis does not require much time, right? Just collect the data, think about it, collect the data. It will take 5 seconds. Feed the data, click on, select the graph, it will give you the diagram. So play around with this. Okay, very good. Increase HC and to met SL. Very good, super. Now, so once we do that, then we'll enter to the improve phase. The objective of improve phase is to generate ideas and solutions and implement them. Okay, so let me cover some of the topics in improve phase basically which we have. So let me just show you some of the tools basically we have seen in the improve phase, okay, which we are going to cover today. So I will cover setup time reduction, non-value added activities, cellular. See, these are very simple one to understand. Okay, Then there is something called as controlling WIP, or there is a Little's law. I will cover the Little's law, which is very interesting one. Okay, 5S, etc. Let me touch upon this. So let's go one by one. Let's see how much we can cover about it. Okay, these are some of the lean tools. Plus, there is something called as a scamper. How many of you remember scamper? Scamper किसको पता है? You remember SCAMPR we discussed in the yellow belt session. Just type me in the chat box. That is also one of the very powerful tool, okay? To generate idea then solution. Now, very good. So I think almost everybody remembers scamper, right? Super. So let me just touch upon some of the tools which we use here. I'll give you a very simple example so that you can understand it. Now, how many of you have multiple products and you have to take the product changeover? Just type me in the chat box. Product changeover. You have to take the product changeover. Me. So you have multiple products. So from X product to Y product. For example, let's say I am a biscuit manufacturer, and from let's say Britannia Marie, I want to make Britannia Good Day. So the same process, same conveyor, same line, I want to change the product from A to product B. So what is the change over time? And that change over time from between product A to product B, it's called as setup time. Setup time. Let me give you a simple example. Like day one, SIPOC, we became the tea stall vendor, right? If you remember tea stall vendor, okay? Similarly, imagine you have another stall of the juice. Now let's become the juice vendor today. Now the juice vendor has a juicer, a mixer juicer. Let's say this is a mixer juicer. Okay, this is, let's say, the mixer juicer. And this is a mixer, and there is a blade here, and you make your juice, okay, inside that. Now, right now you are making apple juice. There is a customer who demanded apple juice, so you are making apple juice. And now there are a lot of customers who have come, and all of them are asking for orange juice. And you have only one mixer juicer with you. Okay, correct? So the situation is, you need to complete the apple juice, pour it, give it to the customer, and then you start making orange juice. But in between whatever activities you are doing, that is called as a setup time. Stick-up, everybody understood the situation, very simple. Setup time is between product A to product B, whatever time it takes from product A, which was running, to product B, which is yet to run, right? It's called as, yes, setup time or a changeover time. So what is the changeover time? What are the big elements? So this activity was done in Toyota. This activity was done in Toyota. There was an engineer in Toyota. His name was Shingo. And this engineer was given a task to reduce the setup time, because at that point in time, Toyota was taking somewhere around 24 to 48 hours of changeover. 24 to 48 hours of changeover between car 1 to car 2. So he was given this task to reduce that, and this guy, by using this methodology, reduced the changeover time from 24 to 48 hours to below 10 minutes, less than 10 minutes. That's why this method is also called as SMED. Everybody please type SMED in the chat box. SMED. SMED stands for single minute exchange of dies. So die is an equipment which is used in the manufacturing. Okay, let's not get into technicality of it, but single minute exchange of die, that means from 24 to 48 hours it has brought down to a single digit minute, which is less than 10 minutes. Okay, So what were the principle they used? This is what we are learning right now. So the first step is called as preparation. Let's consider the same example of orange. Now what is the preparation here? For making orange juice, first we'll have to take the oranges, bring the oranges, maybe from the market or maybe from the store. Okay, whatever storage we have. So oranges taken, then peeling off the oranges, maybe first washing them, then peeling them off, taking the seeds out of the oranges, maybe chop them, cut them, maybe add some masala and all. So let's make the preparation. So this is called as preparation. Are you understanding? So this is called as preparation. Now tell me, the apple juice is being made here. So apple juice का ये चल रहा है. Can you do it parallelly? Yes. So juice is being made, right? Without sugar. Okay. Sorry, I'm not a juicer. So so if it is sugar, it's sugar. Okay. Now my question is this. Now the apple juice is being made right now. Can we do this parallelly? This peeling of these oranges, washing them, and then chopping them, removing the seeds, okay, and making them ready for the next round. Ready? Yes, we can do this. This is called as external activity. What is external? There are two types of activities, external and internal. External activities are those activities which does not require machines to stop. So we don't have to stop the juicer. We can parallel do this activity. So this is called an external activity. Now let's say the apple juice is done. So you pour the apple juice, serve it to the customer, and you wash that pot, right? That jar. And now let's say you want to change the blade. Because for apple, maybe you had a heavy blade. You need a little lighter blade for oranges. So you change the blade. Now can you change the blade and can you do the adjustment of the blade when the machine is on? No. That's where you need to stop the machine, and those activities are called as internal activities. So these two activities are internal activities where machine needs to be stopped. So setup meaning you stop the machine, you clean it off, and you remove the blade, you put the blade, and then you do the finer adjustments like tightening, balancing, alignment, and all those things. So setup and adjustments are internal activities where machine needs to be stopped. And then comes the test run. What is test run? Test run is the thing, but before we start the producing it in numbers, in continuous, we first take a sample. We test the quality of the sample. If it falls between the specification, then we go for the mass production, right? So these are called test run. Again, this is also external activity which can be done parallel. Now understand this. What they have done this external activity parallelly. So this 25, generally preparation takes 25 minutes, sorry, 25%, setup 5%, adjustment 20%, and test run 50%. So what they have done, they have eliminated preparation. And now what they have done, they have standardized certain norms. For example, if let's say for oranges, if I fix the vendor, if I fix the quality of oranges, if I fix the process of washing, peeling off, taking the seeds out, etc., complete standardization, and amount of salt, amount of sugar, amount of masala, whatever it is, okay. So if I standardize it, at least I will get the first cup of this within specification, right? If not exactly hitting the target, but at least within specification. Yes or no? Everybody? If I follow the norms very stringently, so the test run will at least fall in the specification. Just give me yes or no in the chat box. If I follow very stringent norms, correct? Of course, then the little adjustment I can do later as well, right? So after sipping that, maybe let's say test, you can add a sugar. But the first glass will be at least within plus and minus range of that specification, right? So what they did, with the stringent norms, they have eliminated test run of 50%. So they remain with this 25% of the time. And in that also, They use some techniques like time and motion study. Okay, they there also they use techniques like Pokayoke. They use techniques like standardization and reduce the time as well. That's where only 5% time remain and more than 95% time was eliminated by using this simple method called SMED, which was done by Shigo Shingo. Are you clear? Principally, are you clear about how you can eliminate the activities? First you differentiate between external and internal. External you eliminate it, and internal you reduce it. This is a method they use for the SMED technique. Clear? How about external forces like power cut, machine breakdown, raw material availability? So all these things has to be ensured before you take the changeover. Okay, for example, let's say raw material availability. So you need to make sure that this raw material, which is let's say oranges are available beforehand before we take the changeover. Are you understanding? Then only we can. So it's not like you stop the machine and now you are running around to see where are the oranges placed, right? So this also is the external activity to make your raw material available. Okay, so you can bifurcate the things about stuff like this. Now coming back to machine breakdown and power cuts. Now there are few factors. Let's say power cut may not be in your control. There are a lot of industrial development corporations like MIDCs and GIDCs, and there are so many areas where there are systematic power cuts. There are unplanned power cuts as well, which are not in our control, so we can plan accordingly. Okay, so during power cuts these people give the weekly offs. During power cuts they take the maintenance activities. So okay, so those kinds of activities they basically plan. All right, so this is called as SMED technique, guys. All right, so now another one is called as so this is explained internal activity, external activity, etc. Okay, so how they can use that. Now let's talk about removing non-value added activities. Okay, everybody knows Teamwood, right? Just type Teamwood in the chat box. TIMWOOD. Teamwood. Everybody knows Teamwood. Yes. In yellow belt we covered Teamwood as well. Transportation, inventory, motion, waiting, overproduction, overprocessing, defect, right? So in your green belt it is covered as well. So whatever covered in yellow belt I'm not covering once again. So here there is one area where you can do it, which is eliminating non-value added, the activities which add no value. Okay, so there are three types of activities: value added, non-value added, and business value added. Let me give you example. Value added meaning, let's say you want to go from let's say your home to airport. So what is value added for you? You book a cab. So cab taking you from your home to airport safely within time is value added. You are ready to pay for that. That is called value added. What is non-value added? Cab got a breakdown and you waited half an hour to repair that. That is called as non-value added. Are you understanding? And what is business value added? Business value added is nothing but, let's say, cleaning of the cab, cleaning of the seat, okay, or fueling of the cab. These are called business value. That is not adding value directly to you, but indirectly it is adding value. Okay, cleaning the cab from within, from inside. Okay, for example, before you join in, that the driver was cleaning the cab. So he says, sir, can you just wait for a couple of minutes or 5 minutes? Let me clean a cab a little, because the last ride there were small kids and they have just made a mess out of it. So let me clean. Now it's not value adding for you, but for your hygiene, for your cleanliness, it's actually right. Okay. Then maybe that the guy is waiting for 5 minutes for fueling the cab, fueling the tank, which is the gas or the petrol, right? Without which the car cannot run. So it is not adding value to you, but it is actually business value adding. Like for example, training to the employees, it is business value adding. Maintenance of the machines, it is business value adding. Clear? Value added, non-value added, business value added. Non-value added is all about Teamwood. All teamwood is non-value added, where customer is not willing to pay for it. Are you clear? Just give me yes in the chat box. This 3 differentiation is clear. Value added, non-value, business value added. Yeah. Very good. Super. Now, what you do here, you first map your process like this. Okay. So process diagram or process flow diagram, everybody knows. A very simple process flow diagram. You can do like this, like graphically, or you can just write down the steps, step by step. And then you actually, each and every activity, you label them value added, non-value added, or business value added. So value added, maybe you can color them yellow or green. Non-value added, you can color them red. Business value added, maybe you can color them something else. Okay, white maybe. Okay, so then your objective is to eliminate non-value added activities from the system. Now you cannot eliminate 100%, but try to eliminate or reduce them as much as possible. Okay, once you identify this, an easy way of identification is teamwood. Ask the question, is it transportation waste, inventory waste, waiting waste, etc. Step by step you go, keep on labeling them, and then try to eliminate them and reduce it. Just keep the value added stuff in the process, and this is called as NVA, non-value added elimination process. Okay, elimination may not be 100%, but whatever you can eliminate, what it does, it reduces the turnaround time, the timeline. It reduces the resources required. It reduces unwanted stuff. Okay, so it simplifies, and this is one of the very important factor in lean. We are cutting down unnecessary fat from the process and making the process leaner and thinner. Clear conceptually? Just give me yes in the chat box. See, these activities now, when you do it in your process, that will give you more confidence. Are you understanding? Yes. Right now what we are doing here is conceptually we are learning this. Conceptually. But concept understanding is also very, very important. If your understanding is clear, what is value added, what is business value added, what is non-value added, then implementation becomes easier in your case. Alright? Super clear? Now let me share something which is called as Little's law. Okay, Little's law. What is Little's law? Let's try to understand this. Let me explain this Little's law with a simple example. Okay, so Dr. Little was a professor in Massachusetts Institute of Technology, which is also called as MIT. Okay, now he was a professor. According to him, this law was named. Okay, named after him, Dr. Little's law. Now, according to him, the lead time is directly proportionate with WIP and inversely proportionate with completion rate. Let me explain you with a very simple example. You can easily understand this with this simple example. Lead time is directly proportionate with WIP and inversely proportionate with the completion rate. Let's simple example lete hain. Imagine you go to a ATM to withdraw some cash. So let's say this is ATM. Let me draw here ATM. This is ATM machine. Okay, automated teller machine, and there are 5 people in the line before you, and let's say this is you. Now this ATM takes 5 minutes cycle time. That means every person takes 5 minutes to withdraw the cash. Now you tell me, what is the lead time for you to withdraw the cash? What is your lead time? The moment you arrive at ATM till the time you withdraw the cash. This is called the lead time for you. Now every person takes 5 minutes. So what is the lead time here? Type in the chat box. Very simple question. Yeah, give me one answer. Don't give me 2 answers. Give me one answer. How much time will it require for you to withdraw the cash? Withdraw the cash. That is the lead time. It should have the cash in your hand. 30 minutes. Correct? Because these 5 people will have 25 minutes, and this is for you, which is waiting vest. W for waiting. So this is non-value added, NVA. And then 5 minutes, which is value added for you. So what is lead time? Value added plus non-value added. So the total is 25 plus 5 is 30 minutes. Clear? So in the first case, it is 30 minutes. Now in this case, these 5 people are work in progress or work in process. Are you clear? So 5 number of people are work in process, and you are the 6th one. Are you clear with you? Are you clear with this concept? Okay. So more the WIP. So let's understand this. Now, how do you reduce your lead time? First, you work with WIP. What Dr. Little says, it is directly proportional to WIP. Though, so more the WIP, more the lead time. Okay. Yes. Yeah. Okay. I got it. It was 30, but you just pressed 3 and 0 was not pressed. Okay. Anyway. So coming back to, it is directly proportionate to the WIP. So more the WIP, more will be the lead time. Less WIP, less will be the lead. Let's say second attempt, let's work on the WIP. Instead of 5 people, now there are only 2 people. Only 2 people in the line. What will be the lead time now? Type in the chat box, everybody. What will be the lead time? So I just cut down the WIP from 5 to 2. My lead time has become 15 minutes. So round 1, it was 30 minutes. Round 2, I cut down the WIP. It has become 15 minutes. Clear, everybody? So 2 people will take 10 minutes waiting time and 5 minutes for me. Now coming back to completion rate. Okay. Now let's try to understand. This ATM takes 5 minutes for dispensing the cash for every person. Let's say I automated this machine again. I increased the speed of internet from 2G to 5G. Now this same ATM has started dispensing the cash in 2 minutes. So I have worked in the completion rate. Okay. So I reduced down the cycle time. My completion rate has increased. So I can serve more people now. Now tell me the same fundamental, 2 people in the row. How much time now I will take to dispense the cash? Everybody will take 2 minutes only. 6 minutes. Absolutely right. So these 2 people will take 4 minutes and you will take 2 minutes. So total is 6 minutes. Are you understanding? So by working on the WIP and by working on the cycle time or the completion rate, you can absolutely reduce your lead time from 30 minutes to 6 minutes. So there are various ways. See, understand this. In the first case, we reduce our setup time, which is the changeover time. So time is reduced. Second example of non-value added activities, by removing unwanted activities, we reduce our lead time. By using the Little's law, we reduce the WIP and we work on the completion rate as well. Ultimately, we are reducing our lead time. Okay. So the main objective of working all these activities is to reduce our lead time. Clear? Just give me quick yes in the chat box. If there are 3 people already there, no, there are 2 people, not 3 people. Only 2 people in the row, no? That's what we said. Only 2 people, so 2 people will take 4 minutes and you will also take another 2 minutes, so total 6 minutes. Okay? Clear? So this is called as Little's law of lead time reduction. So you can use this. Make sure your WIP, your inventory levels are down and your cycle time is also reduced. Then you can reduce your lead time drastically. Okay. Understand conceptually. See, these tools while implementing, first once your fundamentals are clear, then you can easily take care of the complexities while implementation. Your fundas should be clear. Once fundas are clear, then obviously it will not be very easy. Okay. it will be having some troubles, it will be having some variations, it will be having some challenges. Okay, but your fundamentals should be clear. Once it is clear, then it will be very easy for you to implement these kinds of tools very effectively. Okay, there is another tool which is very, very important, which is called as Pokayoke. How many of you have heard about Pokayoke? Pokayoke, which is also called as mistake proofing. Have you heard about Pokayoke? Mistake proofing? Anybody? Yes? What is that? Error proofing or mistake proof? Yes, so here Pokayoke meaning, it was, see, earlier we used to learn about foolproof system. Have you heard about foolproof system? Just give me yes in the chat box. Lot of times when we purchase any equipment, any electronic equipment, the salesman generally use this term called foolproof system, or an electrician or a technician, that those people will use a term called foolproof system. The original spelling, now understand this, original spelling of foolproof, so we understand it is foolproof, right? The original spelling was not like that. The original spelling was this: foolproof. Fool meaning a mad or a crazy person. So it was saying like even fools can use it. So it was like calling customers the fools. Are you understanding? So then basically they changed the terminology, and instead of foolproofing, they started making the terminology called foolproofing. But the concept remains same. What they think, that people will make crazy mistakes like fools. Okay, like say your machine is rotating, they will put their hand. Are you understanding? Right? They will get electrocuted. So you need to design the systems such that that machine should stop. Even a fool puts a finger, machine should stop, and he should not get harm. In in lot of industries, let's say there is a rotating equipment. If you go closer to that, machines automatically stop, because there are sensors. That sensor senses the movement, and it immediately powers off the machine. Those kinds of things are called Pokayoke. Now, we have seen Pokayoke happening everywhere in our life. You tell me, where have you seen mistake proofing? I'll give you a couple of examples. Yes, exactly. The lift. I was about to tell the lift, and you read my mind. Okay. Lift. While entering the lift or coming out of the lift, the sensor senses the movement, and the door does not get closed. That is a Pokayoke. Okay. In the same lift, if the weight of that lift goes beyond certain limit, the lift does not start. Right? That is also Pokayoke. Are you understanding? Yes? It's USB, absolutely right. The SIM cards, the car locks, the socket position, the design of the socket. So you cannot fit another socket. Okay, your laptop chargers as well. The same laptop chargers to be used to the same laptop, otherwise it will not work. Same with the mobile phones as well. Right? These are called Pokayoke system. You go to metro stations or airports, you have the authorized boarding pass or the authorized ticket. If you show to the machine, then only the doors will open, right? And you'll get the authorized entry inside, right? So these are called as Pokayoke. There are a lot of Pokayokes which in the electronic thing. Let's say, for example, there is a mobile number you have to enter, and if you enter 9-digit mobile number, it will give you a red signal that a wrong mobile number has been entered. Okay. Even nowadays, AI also is being used. If you enter 9999999, okay, it will immediately give you a false alarm that this is not the right mobile number. Okay. Sometimes now it checks in the repository and check whether it is an authorized number given to the person. Okay. MRI machine scan is going on, you open the door, it will stop. Exactly. MRI machine is also very good Pokayoke example. Okay. So these kinds of stuff also. Now, who invented this? Guess who? The same guy, Shingo. Okay, this was the engineer who invented Pokayoke, and when he started, he took the target that any automation, any Pokayoke I will make it below $50 investment, less than $50 investment. Okay, and he taught this to a lot of Toyota engineers, and they also followed the same thing, but only to get approval is less than $50. So the original concept was you can use the natural phenomena, the Newton's laws and all these things to make this work. Okay, so then it was not AI was not there, and computers were not there, or they were there but they were not advanced as what we are having right now. Okay, so that was the major source of mistake proofings we had. Okay, so we can think about mistake proofing. We can use AI tools nowadays. You can ask AI about designing such kinds of mistake proofing to make that work. Okay, so all these tools plus Camper, they generate ideas. Okay, once you generate ideas, one of the very important tool we use to actually see, all the ideas cannot be implemented, right? So we have to basically prioritize those ideas, and one of the very powerful tool we use is called as EB matrix. EB matrix. Everybody please type EB matrix in the chat box. EB matrix stands for effort benefit matrix. So once you generate a lot of ideas, EB stands for effort benefit. So what is bespoke IOKs and idea generation, brainstorming. Okay, then we go for effort benefit just to prioritize them. Okay, so here let's say solutions are listed. So these are solutions. Effort benefit I have just modified. Fit me na, we give rating on, instead of rating I have just made it kind of discrete data. Okay, instead of a rating on the scale of 1 to 10, I have made it discrete, like high and low. Very simple. Okay, for example, let me give you example. Let's say these are 4 kinds of solutions. Various solutions are there. Okay. Now, just a second. So let's say solution number 1 is having low effort and it has having low benefit. I'll give you examples so that you can understand. Okay, let's say one of the idea is, let's give awareness session to our team members. Awareness session of 15 minutes. So it is the effort is low, and when we give the awareness session about the new modification, etc., of course it will give the benefit that people will become aware. So with this solution, the effort is low, benefit is also equally low. So I will write low effort and low benefit, L and L. Second type of solution would be low efforts and high benefits. A very small, this is called as low effort but high benefit. Low effort, high benefit. Okay, 45-day challenge. Low effort, only effort of 45 days, benefit is very huge because you are getting green belt and black belt certification, huge impact on your career. Low effort, high benefit solution. There are third category where high efforts and high benefits are there. Example, I'll give you example. In the automation, there will be huge investment, capital expenditure, right? So effort is very high, but benefit also will be equally high. So it is called high effort, high benefit. There is fourth category where efforts will be very high, but benefit may not be that great. So those are called as high effort, low benefit. So if I plot them on a matrix like this, where efforts will be on the x-axis and the benefits will be on the y-axis. Okay, so there will be these 4 quadrants I will get like this. The first quadrant, first solutions will fall here where low efforts and low benefits are there. Those solutions are called as just do it solutions. I fondly call them as Nike solution because just do it is the tagline of Nike. Just do it, because the small effort solution, just do it, don't think much, let's implement it. Okay, the second type of solutions will come here. These solutions which are low effort and high benefits, these solutions are called as must do it solutions. Must do it. The third category will fall here where efforts are high and benefits are also equally high. You need to escalate this to the management. Escalate to management for approval. Are you clear? And then the fourth category is high effort but the low benefit. So we can just drop it. Drop those solutions. We need not to worry about them. Remove them. Okay, so just do it, implement them. Must do it, implement them. Third category, if management approves it, you implement them. If they do not approve this, you drop them. And the fourth, you directly drop them. Okay, so this, if you do this classification, then it will be very clear for you which solution to be implemented and which solutions to be dropped. Okay, so this is called as effort benefit analysis. Are you clear? Or matrix? Very simple. I have actually simplified this in a great way. So if you use this low and high kind of categories, you can easily bifurcate them. Clear conceptually? Okay, so whatever ideas you have generated, solutions you have generated, you can classify them into this matrix and prioritize them. Okay, so first and second, and if third after approval, you make the list and then you make the action plan. What is action plan? Action plan is nothing but implementation action plan. So what are the major contributors in implementation action plan? Is this. So implementation action plan. What is implementation action plan? Whatever finalize actions, activities. Okay, okay. The solution is there is a small automation to be done. So if automation is one of the solution they have finalized, so what are the activities? First activity is first of all, find out vendors online. Find vendors, then take quotations, right? And then shortlist, negotiation and shortlist, and then finalize, right? Yes, robotic installation or robotic automation. So now every activity, let's say activities will have the accountable person. Activities will have accountable person. Okay, accountable meaning the person who is accountable to for the activity. Let's say finding out vendor, let's say Rahul is accountable. Taking quotation, let's say Sonali is accountable. I'm just giving random names. Then negotiation, maybe Sahil is a negotiation, purchase manager, he will do negotiation. And the manager of Sahil, let's say Suhas, is finalizing the vendor. So then they have a specific target date. Let's say Rahul will do it on 1st of June. this is the target date of completion, and you give the date as well as this one as well. Okay, after finalizing vendor, taking quotations from them by 15th of June, Sonale will do it. Negotiation by 25th of June, and by 30th of June, so within 1 month, the finalization of the activities will happen. Are you clear? And then you can update the status. As a project leader, you have to make for each and every solution this kind of a implementation action plan, and then you have to review it during your discussions. Clear, everybody? Just give me quick yes in the chat box. Once you make the implementation action plan, then you start implementing, and that's where you get the results. See, this all things will take time. That's why if you remember, day one I said you should not commit on 7 days and 10 days results. It takes time. If you want real results, it takes time, maybe 3 months, 4 months, sometimes 6 months, according to the complexities. And again, another one thing is that because we are working majority of the work, we are doing part-time basis. Considering our daily routine activities, we are doing these activities, right? Additionally. So it takes time, generally. The bottom line is it takes time. Okay? Yes? Super. So time requires time. Fantastic. So once this is done, our implementation is done, then you will start getting some results. That's the time we implement our control plan. Let's do one thing. Let's take quick 3 minutes break, right? 3 to 4 minutes break, and we'll be back by 8:45. What is the time right now? Just take 3 to 4 minutes break. 8:40, right? So 8:45 we'll come back at 8:45 sharp. Okay. So let's take a quick break. Then we'll come back. We'll discuss about control phase. Okay. By 9:30, I will give you the steps about the examination, and then we'll close the session. Okay. Chalo, let's enjoy your 5 minutes break, and then we'll go back. We'll come back. Okay. Once you are back on your seat, please let me know I am back in the chat so that we can start our session. Just type I am back. Super. All right, let's begin our journey in the control phase, which is the final phase of the DMAC framework. The important, equally important phase, but the least taken care of phase. Okay, and this is a phase where most of the people lose a little bit of their focus because they start getting results. Right, the moment they start getting results, it's like you do the weight loss program, you do exercises, you do the dieting, yoga, and whatnot, and you get some positive results. The moment you start getting positive results, that controls start to drop, and suddenly a party comes and your mind says, "अरे एक दिन खा लेते हैं, कुछ problem नहीं है." Yes, you have reduced your dinner diet drastically, but in the party then there is all oily and junk food is there, and then your mind says एक दिन होता है, कुछ problem नहीं है, then that becomes the habit once again. Whatever improvement you have done, it goes down. So control phase is very, very important phase when it comes to, so it's all about monitoring and controlling, right? We all know that this is all about y is equal to function of x. In this, we monitor, in the control phase, what we do is we monitor y and we control x. In the control phase, we monitor y and we control x. We cannot control y. Output is y, right? This is to monitor. The weight is the y. What we need to control? Weight cannot be controlled. Understand this. I can control my diet. I can control my, so these are x's. I can control my yoga. I can control my exercise time. I can control my, the gym. So these are my controlling factor. These are my x's. If I work on x's, I focus on my x's, have a very stringent control, then my y will show the result. I will monitor my weight. I will monitor my cholesterol levels. These are my outputs. So y is my output, right? And x is my input. So I will monitor my output and control my input in this phase called control phase. So monitoring and controlling is the main objective of this control phase. Now, in this, what happens generally is, if you see here, let's say our project starts from here. Let's say our project, so our process was like this. Then we did a project and had some improvement. So we reached here. This is after improve phase. So it is going up. Now we are standing at this point. If we don't do a control phase properly, improvement will fall back again and you will come back to the same level once again where you had started. But if you sustain it, then it will go. That's what I always say this. Everybody, if you heard about PDCA, Edward Deming's PDCA cycle. This PDCA cycle talks about this only. You improve, you sustain, you improve, you sustain, you improve, you sustain. So define, measure, analyze and improve is this line, and this is my control phase. So this is DMAC. Again, DMAI is this and this is my C. DMAI is this and this is my C. This is how the step-by-step control mechanism works, and this is called as continual improvement. There is no monitor much, right? No, but monitoring is required. Monitoring is always required, because sometimes what happens is those controlled X's are there, but there is something else which is impacting my Y. Are you understanding? Yes. So control X is there, on our X's are there, but there could be some other X which is propped in, and now that is impacting. So monitoring is also very, very important. Clear? So this is major objective of control phase. So the most important factor, most important tool we use, there are two most important tools. One is called as, so this is we standardize the new processes, we monitor Y, and we control X's in this control phase. So very important plan is called as a control plan. So let me show you a control plan example here. Okay, so this is called as a control plan. Let's try to understand what is control plan. Okay, so control plan is a plan where the process steps are written. So you remember in SIPOC we listed the process steps. So P stands for process. So all the process steps we will write here in the first column. Then the metric, whether which is Y or which is X. Okay, so this process is step is about Y or which is X. Then unit of measurement, whether it is kilogram, centimeter, gram, pressure in degree centigrade. Okay, if it is call timing, then it is the minutes, okay, or hours. Who will record this? So let's take one simple example. Let's take a simple example of let's take a simple example of raw material inspection. Okay, give me RM inspection. So I'm just writing in a very short form, inspection. Okay, so RM is one of the X. So we are talking about one of the very important factor, which is raw material. Okay, so unit of measurement, let's say, imagine that is, we are checking the weight of that. Okay, so the weight is in kilogram. So I will write the unit of measurement is in kilogram. Who will record? Let's say Rahul will record this. Okay, how often it will be recorded? Every shift. Every shift it will be recorded. Okay, type of chart. Now there are types of chart we are going to learn, but yesterday whatever chart we learned, that chart is called as individual chart or eye chart. I will give you another 6 types of chart right now after this. Okay, after this tool I will discuss about the control charts, where we will discuss and understand 6 different types of charts, 7 in total. Okay, one we have already seen. What to response? Let's say here Rahul has given a task that while checking, imagine while checking, if the weight is less than 40 kilogram, I'm just giving you example, kilograms. Okay, this is the time. If the weight of the raw material is less than 40 kilogram, immediately Rahul will respond. So who will respond? Rahul will respond. What will they do? Meaning, so Rahul will call the manager, the procurement manager, let's say Sahil. Sahil will be called. Okay, Sahil will be called, and Sahil will check himself. Then Sahil will immediately call the vendor and ask for the clarification why you have sent the weight less than 40 kilogram, where we have specifically mentioned we want lower specific, we want the weight between 40 to 45 kilograms. So this is my lower specification, this is my upper specification. If it is less than 40, we are going to reject it. Are you understanding? So comment is, so vendor will, take the material back and send the material again within couple of days. So that will be the comment which will be here. Are you clear? So this is a step-by-step procedure for each and every point. critical steps and critical factors which we have identified, if we have a very stringent monitoring and controlling mechanism like this, then we will not have variation going inside the system. Are you understanding? So if you understand this, see, if you know the input process output mechanism, right? Input, process and output. Now there is more variation in the input, there will be more variation in the output. Are you understanding? And there will be huge strain in the process parameter also will have the huge strain, because there is lot of variation and the jerks coming in. Less variation in the input, less strain in the processes and less variation in the output. And that's what we are basically doing. So we are putting very stringent controlling monitoring mechanism on the input so that the variation can be reduced and it will not pass on into the process. And this is called as a process control plan. Are you clear? Just give me yes in the chat box. Super clear with a very simple example. This is called as a process control plan. I'll give you another example. I am arranging a training program. One of the process step is checking the mic system, checking the the audio mechanism, audio system. So metric is X. This is one of the input parameter, which is the mic system. What is unit of measurement? The availability unit, number of unit. Let's say the cell availability. In the mic there are few cells, right? You have to put some cells in the mic if it is a battery operated mic. So unit of measurement is availability of a cell. Who will respond? Let's say Siley is one of the person who is responsible. So Siley will check. Okay. How often it will be recorded? Before the training program, 1 day before training program, she will record the number of cells available in the mic as well as the spare cells. Type of chart I am about to speak. Then what to respond? Let's say if Siley understands that cells are not available, she will immediately respond to her manager, and manager will immediately call the vendor and arrange the cells. This is a control mechanism. So when the training starts, the cells will be available, the mic system will not fail. This is the control mechanism. Clear? Which is clearly defined. And it goes in the standard operating procedure so that it will be followed in each and every time. Okay. Now let's talk about, once this is done, then the next part is called as the control chart. So, okay, so let me just share the different types of control charts here, and we will do the exercise quickly before we close the session. Okay. Next 15-20 minutes, we'll do the Minitab exercises, very interesting Minitab exercises. And let's draw this control charts, the types of control charts. How many of you remember the father of control charts? I mentioned this name yesterday or day before. Who was father of control chart, or father of statistical process control? Who can tell me the name? Yes, app's name is Walter Shewhart. Walter Shewhart. These control charts are also called as Shewhart charts. Okay, Shewhart charts. As we go along in the black belt level, maybe we'll discuss about what are the different control charts levels, which are the control level limits which are set. Okay, yeah, Dr. Walter Shewhart, who is called as the father of control charts and statistical process control. Okay, so control charts types. Now, if you have the continuous data, write this down. If you have continuous data, you will have I chart, you will have X bar S chart. Okay, and if you have this table right now, just make a table along with me, which I am just making. If you have a discrete data, just make a table. I'll explain each and every part of it. Then comes the defect and the defective, Then comes the constant lot size. First make it and then we will discuss. Constant lot size, lot meaning the sample size, and the second is variable lot size. Okay, and then make a table like this. And so if you have a constant lot size, and if your data is talking about the defects, then basically you use C chart. If you have variable lot size, you make U chart. If you are talking about defective data, then constant lot size makes NP chart in defective, and variable lot size make P chart in defective. Let's make this table. And once your table is ready, just type done in the chat box. You can take a screenshot if you wish. Let's try to understand what is this, and then we will do the exercises with all this. I chart we have already done yesterday only. On the same chocolate weight example, we will do X bar and X bar S chart. Okay, we can make I chart as well if you wish. Now, what is constant lot size and variable lot size? Imagine sample, lot meaning sample size. The day one I spoke about sample and population. Well, when I explained about descriptive and inferential statistic. Sample is the representative of the population. So sometimes we have a fixed sample size that is called a constant lot size. It's fixed. No matter what, I will take 10 samples only. No matter what, I will take 10 chocolates only to check the quality. That is called as a constant lot size. Variable lot size, sometimes you take 5, sometimes you take 10, sometimes you take 15. That is called variable lot size. When constant lot size is there, your chart will be different. When variable lot size is there, chart will be different. Now comes to defect and defective. Now if you are taking the data of defects, that is called as, you remember I mentioned about let's say the shirt example. I think it was given on Monday, this one. Okay, I am making the shirt. Okay, let's say this is the collar and this is my shirt and this is my pocket. Okay, now this is the shirt. So if my data is how many defective shirts we have, then I will go for these two charts according to the lot size wala thing. Okay, but instead of that, in the shirt there could be multiple defects, right? For example, if you remember, there could be stain defect, there could be stitching defect, there could be buttons defect, right? So if we are counting the number of defects instead of defective, then I will go for C and U chart according to the variable and a constant size. Yeah, defect meaning within that product or service, okay, even one defect comes, that makes that product defective. Defective is entire unit, and within that unit, how many defects are there? If you have a data of defects, you go for C and U chart. If you have a data of defective, you go for NP and P chart. Okay, clear? यहाँ तक conceptually clear है? Just give me yes in the chat box. We will do the exercises that will make it more clearer. Clear? Everybody with me? Yes, no. अगर no है तो no बोलो, so मैं explain करता हूँ. I will give you examples. Okay, example लेते हैं so that you will understand it better. Okay, so I will give you example. Let's start from C chart. Okay, let's start from C chart. I'm just sharing the example of C chart with you. So when do we use C chart? Just take this example, open this file which I have just shared with you, and in the recording I will put all the files for you. All the files I'll put for you, okay? So that you can refer that in the future. You can download that file as well, okay? Open this file called C chart. We will do all these 3 or 4 charts, then X bar or X bar X, okay? So as time permits, we will do that. Yeah, once you open, let me know in the chat. Yes. Opened. Very good. Let me just have confirmation from all. Yeah. So first we'll check C chart. When do we use C chart? When we have constant sample size and we have defect data. Constant sample size and defect data. I'm just waiting for my file to get open. Just give me 5 seconds, okay? It is opening. Because there are a lot of files open on my system and it is taking time. So I'm waiting for myself as well. Okay. Everybody has the laptop and mini tab. If you are not traveling, you can do that. Otherwise, when you go back home, you can do these exercises. Okay. Aja bhai, kidhar gaya? It is taking too much of time because there are so many files open on my laptop because there are a lot of projects going on. Just give me a second. Yes, okay. All right. So I have got one file open, thankfully. So here we go. So this is about the papers and the mistakes. Now, in the paper, there are constant questions, right? Let's say, for example, in the yellow belt examination, we had 15 questions. In the black belt examination, we will have 50 questions, 50. Green belt, okay, green belt. In black belt, there will be 100 questions. Master black belt, there will be 150 questions, right? So the number of questions are the sample size. So sample size is fixed. Let's say, imagine there are 20 questions and errors meaning the number of wrong answers given, that are the defects. Okay, that entire question paper is a unit. If I have a pass or fail data, that would be a defective data. Pass or fail is a defective, but now we are measuring the defects. If within the question paper, how many defects you have made, how many errors, how many mistakes you have made. Clear? So constant lot size and defect data, go for C chart. So go to stat, control chart, attribute chart. See, these are called attribute. Discrete is nothing but attribute, okay? And you select C chart. C chart is at the bottom. So we have stat, control chart, attribute chart, C chart. Once you click on that, you will get this and just select the error wala column. That's it. And click on OK. Don't do anything else. And you will get this. All right. Now, here we need to, so I'll repeat again. You open the file, right? Go to stat, control chart, attribute chart, and C chart. Just follow this path, please. Stat, control chart, attribute chart, C chart. Once you click on C chart, here there are two options, paper and error. Don't select paper option, just select error column. Double click on error, that's it. And click on OK, you will get this graph. Got it? Jyoti, which option you are not seen? Yeah, Krish got it. Jyoti, did you get it now? Got it now? Very good, super. So now here we have to just think about this what you can say, the line, which is the center line, which is the average line. It is called a C bar, okay, which is the average line. UCL and LCL. LCL is 0 because we cannot have below 0 errors, right? We cannot make -1 error, -2 errors. So the lower control is at 0, upper control limit is fixed. Now, how do we calculate this? The formula of this is a little different. Okay, so these formulae we will discuss in the black belt level. Right now, fix the graph, check whether any data is outside. You can see there are 3 data points which are going above control limits. So this process is not stable process. Okay, there are a lot of people making mistakes. So this process needs to basically improve. Okay, so we need to reduce the variation. We need to reduce the errors here in this process. Clear? See, fundamentals remain same. We just have to check whether any data going outside of the control limit. That's it. That is the objective of the graph. Clear hai everybody? Just give me yes in the chat box. Super clear? The similar kind of thing goes with the NP chart. Okay, NP chart कब use होता है? When we use constant lot size and the defective data. Okay, we use NP chart. So मैं आपको NP chart share कर रहा हूं. Let me just open NP chart as well. Let me close this because already a lot of files are open. Okay. Yeah, just open this file which I have given. It is called as NP chart. NP chart. Okay. Very good. Once you open it, let me know in the chat. So here you can see the sample size is 50 and here it is defective. Out of 50, how many rejected? How many defective? Okay, here so 1, 1, 2, 2, 0, 0, whatever it is. Okay, so we have a constant sample size and the defective count has been given. So how do we go about it? Go to stat, the same, follow that, control chart, attribute chart, and select NP. Select NP. Okay, and here just select the count, click on OK. Okay, subgroup size में sample को select करो, sample, double click on sample and you select OK. And you get this graph which shows again, in this case, it shows that the process is very much within control. There is no data which is going outside of the control limits. Clear? So the data in this case, earlier data was out of the control limit. This case, the data is within control limits. This is called as NP chart. Whenever you have defective data, go for NP chart. Clear everybody? Just give me yes in the chat box. How much near to 0 process is best? So it depends on your control limits. It depends on your control limits. There is a formula to calculate these control limits. And this is not +3 and -6 standard deviation. Okay. Attribute chart has a different formula to calculate. Okay. So I will take a special advanced session on calculation of formulae, upper control, lower control. Okay. So every chart there is a different formula. So we'll discuss about it. Okay. Clear? This is a defective wala. So this is for the defective. Yeah, so error coming is because I will do it once again. Okay, I will do it once again. Go to stat, control chart, attribute chart, NP chart, right? This is NP chart. Select this. So here in the variable select count, double click on count. In the subgroup here, you have to select the sample. Okay. Either you can select 50 because the subgroup size is 50. If you can select 50, that is also okay. Or if you select the sample column, that is also okay. And then you click on OK and you will get this graph. So when do we use this? See, control phase is all about control charts are basically controlling your processes. Okay. So imagine this is an incoming product. Okay. One way you have a defect counting defects. If you have defects counting, go for P chart, which we just saw. Okay. Sorry, C chart, earlier chart. Now here, if you have a defective count, let's say incoming material is coming in and you are counting number of defectives. So you go for NP chart. When you have a fixed lot size, every shift you are having a fixed lot size to check. If you have a defect data, go for C chart. If you have defective data, go for NP chart. Clear? Understood? Yes. What is the difference between defective and defect? The same case. The example of a shirt, the entire shirt is a defective unit. And in that, if you are counting the defects, so which data do you have? That will define that. Let's say, imagine you have, let's say you have every shirts, how many defects you have. That data you have, then you go for a C chart. If you have how many shirts you are having defective, then you go for NP chart. And every day you are checking 50 shirts, 50 shirts, 50 shirts. Constant sample size every day. And let's say if you are counting defects and reporting that defect, you go for C chart. If you are just counting out of 50 how many defective shirts, then you go for NP chart. Single unit. 50 is a lot. In that lot, how many units are defective? If that is there, then you go for NP chart. The first option is C chart. In 50 shirts, if you are counting number of defects, okay, in the first shirt, there are 2 defects. Second shirt, 0 defect. Third shirt, 3 defect. Fourth shirt, 1 defect. If you are counting defects, you go for C chart. If you are counting the number of defective shirts, go for NP chart. Clear? Very good, very good. Super, super. Now go to the next one, which is U chart and P chart. Okay, let me give you a U chart example. This is the example of U chart. Just open this file of U chart. C chart for defective. So C chart is for defects. C chart is for defects and NP chart is for defective. Both for the constant sample size. Just check the table which I have given to you. Check the table. I'm just showing you the table. See this table. Constant lot size, C chart, and if it is defect data, if it is defective data, go for NP chart. Okay. Now same with variable lot size. Now one day you are checking 50 shirts, another day you are checking 25 shirts, another day 35 shirts. Variable lot size. If you are counting defects, go for U chart. If you are counting defective shirts, go for P chart. Clear? Lot size is varying, go for U and P chart. Same with defective. So use this table. And you don't have to remember it. Just make it once, that is done. And same thing will happen on, let's say you are working in a call center. So a call is a unit. Call is a unit. Whether that call has given the resolution, that's a defective or okay, right? And within that call, there could be multiple defects. there could be multiple. Let's say that call has exceeded the 5 minutes AHT, SLA AHT, that is a defect. Or the caller, maybe the range was poor, that is a defect. Or the caller was less confident, that is a defect. Are you understanding? So there are, in the call there are multiple defects. So which data are you counting? That will define your chart. Okay. Yes, open the U chart quickly. Open the quickly U chart. Once you open the U chart, let me know. Have you opened your U chart? Done? Very good, very good. Chalo. So let me also open my U chart. In this U chart, we have got number of defects, total number of defects. Okay. I think which one I have given in U chart? It's example. Okay. So just give me a second. This is not the one I should be opening. Just a second. Let me open the example U chart and not the exercise U chart. And there is another one which is also called as, yeah, we have a P chart as well. Okay, now U chart and P chart has a very interesting control charts. Okay, yes. Now let me share my screen. In this case, this is the file you have, right? Rooms inspected and defects. Just give me the confirmation. Rooms inspected and defect, right? This is the file. Very good. So in this case, there is a big hotel, a 5-star hotel, and the quality person is checking the rooms every day. So day 1, he inspected 14 rooms, he checked for the quality, and he found 16 defects. Defects meaning if cleanliness is not there, the bed is not done, the toilet is not clean, that is called the defect. Okay. Second day, he has checked 8 rooms. Out of it, he has found 16 defects. So the variable lot size and we have a defect data, we go for U chart. So let's go for that. Stat, control chart, attribute chart, and U chart. You will find everywhere over there itself. Okay, select the U chart, and now the variable is the rooms, the defects. So variable is defect and subgroup size is rooms inspected. Defect is the variable, subgroup size is room inspected, and click on OK. And you will get, wow, this is something different. Again, I will take a special class on this. See, in this case, every lot size is different. That's why for every sample, the control limits are calculated separately. Are you understanding? Because, understand this, because 8 defects, let me just write in the blue one, 8 defects in 16 rooms is different than 8 defects in 8 rooms. Are you understanding? Okay, so both are different. So here the ratio is 0.5, here the ratio is 1. Are you understanding? That's where you can observe here. These are the ratios 1, 2, 0.8, 0.9, 1.5. These are these kinds of ratios. And because these ratios are different, the control limits are also calculated differently. But again, the fundamental remains same. Now you can see this is one data point, this is second data point. So this process is not constant. And plus you can see these are some data points which are very close to the control limits. So this requires some improvement. Okay. So the process is not stable in this case. Clear hai everybody? Just give me yes in the chat box. Everybody's clear? Just give me a quick yes. And let me just share with you a P chart as well quickly. Similar kind of thing, P chart also, when instead of defect, if we have defective, go for P chart. Okay. Now let me share my screen for the P chart. So here same thing, we have got sample size of 56. Let's say there are 50 students in the class, 0 failed. 60 students in the class, 1 failed. Okay, so the lot size is different and this is defective. How many students are failed? Okay, so go to stat, control chart, attribute chart and P chart, right? Let's select P chart. The same thing, go for pass and fail, and subgroup size may select sample size and click on OK. You will get a graph like this, right? This one is pretty much within the control because not a single data point going outside the control limit. And this is called as P chart. Got it, everybody? Just give me a quick yes in the chat box. So it is similar to the C and U chart. Just have to select which graph is absolutely applicable when. Got it, everybody? Very good. Now there is the final graph. Let me share with you the same example, which is the chocolate weight. Yesterday we have seen, right? This is the final graph we will make, X bar R and X bar S. Okay, just open this sample. The same chocolate weight wala example hai. In the second column, if you remember, I explained about sample 1 has got 10, sample 2 has got 10, sample 3 has got 10. So these are the samples in that. Let's open that quickly and we will make something called as X bar R chart and X bar S. Now, when do we use X bar R and when do we use X bar S? Okay, let me first share you that. Let me go on my whiteboard. When we have continuous data, okay, and in that, if the sample size, this one, okay, understand this, if the sample size is greater than 10, S chart. If it is less than 10, you go for X bar R chart. If the sample size is less, go for X bar R. If the sample size is more than 10, go for X bar S. X bar is mean and R is range. X bar is mean and S is standard deviation. S stands for standard deviation, R stands for range. Okay. Now you remember central tendency and dispersion. So X bar talks about central tendency, R stands for dispersion. Okay, range. Range, variance, standard deviation is about the dispersion and mean, mode, median is about the central tendency. So one talks about central tendency, the second talks about the dispersion. Both are calculated in the graph. Okay, have you opened that? Let me share my screen. First we will make X bar R chart. Okay, first let me explain you here. So we are actually, the software will plot two graphs for us. One is X bar, the average. So for the first sample, this is the first sample, 10 samples. Okay, so if I take average of this, it will be X1 bar. Okay, let's say imagine it is 42 point something, let's say 42.5. I'm just giving you raw data. Okay, and then the range R1 will be highest minus lowest. Range, you remember, highest value minus lowest value. Let's say highest value is what? 43.1 is the highest value. Let's say this one. And the lowest value is, let's say, 39.6. Okay, so 43.1 minus 39.6 becomes around how much? It is 3.5, I believe, right? So my range is 3.5 kilogram. My average is 42.5 kilogram. I'm just giving you, okay, the same it will calculate for the second sample, X2 bar and then R2. So the first graph will be calculated, which is R X bar, and the second graph will be calculated about R, the range. Clear? ऊपर X bar होगा, नीचे R होगा, range वाला chart होगा. Okay, so both will be checked. So let's check that. How do you calculate that? Let's go to stat, control charts, variable charts, for subgroup and select X bar R. Just focus on this. Stat control chart, variable chart for subgroup, X bar R. Quickly select. Here we are selecting chocolate weight and subgroup size. We are selecting sample and click on OK. And here is the X bar R chart. Okay, as we have seen, this is the X bar chart here and this is the R chart here. Now this dot is the what you can say, mean of the first 10 chocolates. Okay, so whatever is the data, this is X1 bar, this is X2 bar, this is X3 bar, this is X4 bar, and so on and so forth. Similarly, this is R1, R2, R3, R4, etc. Okay. Now this is here, you can see X double bar. Why it is called X double bar? Because every dot here is the average. And this is average of averages. This line, this green line is average of averages. That's why it is called as X double bar. Are you understanding? Yes? No, see, U chart, etc. is for the discrete data. Raj, are you clear? Now we are talking about continuous data. The weight in kilogram is continuous data. Whenever we have continuous data, we go for I chart, X bar R, X bar S. When we have discrete data, we go for P chart, C chart, U chart, and P chart. So discrete chart हो गए, यहाँ पे continuous chart हम लोग discuss कर रहे हैं. That's the difference, okay? So select appropriate chart when it is useful, okay? Clear everybody? So right now, both the charts are showing there is no outside of the control limits. So the process is fairly stable. Now let's make X bar S chart. X bar S is absolutely similar to X bar R. X bar will remain exactly same. Instead of range, software will calculate standard deviation of each 10 samples. Each sample, okay? Each sample of 10 chocolates, okay? So standard deviation of first 10 samples, standard deviation of second 10 chocolates, standard deviation of third 10 chocolates. So it will be calculated there. Okay, let's make it so that you can understand it. Okay, go to stat control charts, variable chart for subgroup, X bar S exactly below that. Okay, now the same procedure, select chocolate weight, in sample size select sample and click on OK, and X bar S. It will look exactly similar. Exactly similar. X bar is absolutely same, but here the below wala chart, instead of range, actually it is standard deviation. That's the only difference. Both charts are showing it is a positive result. Clear everybody? Just give me yes in the chat box. Everybody's clear? And these are called control charts, which are basically used in our control phase. Okay, good. So that is end of our hackathon. We have covered very briefly all the topics which are covered majorly in the green belt curriculum. Okay, of course the topics which I have already covered in the yellow belt, the topics which are very simple to understand, I have not taken in this hackathon, but all the mini tab exercises and all the difficult topics which are there, which I have taken over there. Okay, yes, Ashutosh ji, which specific question you have, please let me know. I will answer that. Okay, any question you have, please let me know. Now, the people who have gone through the green belt content, who have gone through the hackathon, they can go for the examination. Examination is, basically will be for 50 questions, and it will take around 1 hour. Okay? Yes? हाँ, मैं explain करता हूँ. This one. Yes? Right, so examination is for the 50 questions and 1 hour. Open book test, it will, your notes can be referred. Whatever notes you are taking, you can refer those notes and you can basically give that examination. Okay, once you have been through the entire content, go for the examination And once the examination is done, within 6 working days, you will receive the result. You can immediately start your black belt content. Don't wait for the result. Start the black belt because we have very limited time left, right? So go for that, go for examination and go for this one. If you cannot score 70%, re-examination has to be given. That's it. Clear hai? Yes. So don't hesitate to give the examination. Ek bar give it a shot for this. Okay. Yes. Yeah. Just have to send the message on the mentor number from your register number. Okay. And then, so from the same number where you will get all the, you are getting all the information about live sessions, about the registration, whatever, when you took the admission, from the same number, you will get the messages. Okay. Yes. Minitab exercises green belt में नहीं है, black belt में है थोड़े से, लेकिन green belt में नहीं है. Right. So you can give the examinations on mobile phones as well. Okay. Yeah. So let me repeat some of this. Minitab versus TOST. We don't use any of the software apart from Minitab because Minitab is the, see, there are other softwares as well. There is Sigma Excel. There is something called Geometry, okay, which is a indigenous software, I would say. But Minitab I have seen, which is a very sturdy software along all of them. Okay, that's what I have come across. So coming back to Ashutosh ji's question, this is the last this one. So let me compare X bar R and X bar S for you. Okay, this is X bar R on the left hand side, X bar S on the left hand side. So X bar is the average of each and every 10 samples. Okay, this is X bar. The R is the range, highest minus lowest of that sample, and S meaning the standard deviation. Okay, so let's say for example this dot is the standard deviation of first 10 samples. This dot is the standard deviation of second 10 samples. Okay, second 10 chocolates. Okay, then this one, and then this is the average of all the standard deviation, and the upper control, lower control limits are calculated, and then we have to check whether any data points going outside of or the control limits. Clear? Yes. Yeah. Mentor number is this 9930595248. It is a common mentor number. Any question you have, you can message on that number. Okay. Where will we get the yes, Amit ji, send the message on the mentor's number, and mentors will arrange the examination on your mobile phone. Okay, clear? Super. Now just keep an eye on how many number of days you are already on this, okay, on the roll, because the 45 days challenge will be over. So before that you complete your green and black belt. Okay, next week we are planning for black belt examination, black belt hackathon. And the people who have gone through the black belt content can give the examination of the black belt as well. Okay. Yes. And if you want to go for master black belt and the lifetime membership of SNG, you want to stay in this entire zone of live session. And if you really love this energy, then just share this invitation link. I believe invitation link everybody has received, right? If you have not received, you will receive it within today or tomorrow. Okay, share that invitation link to most of your colleagues, friends, family members, and if 2 of them join our 45-day challenge, you will get a free ticket to master black belt and lifetime membership. Okay, so do not let this amazing opportunity go by. Okay, fair enough. So any question about referral, about the procedure, just send a message to the mentor. There will be a call we are arranging with our advisors as well. Lot of you would have received the call from Vaishali madam. How many of you have received the call from Vaishali madam? Just type me in the chat box. So she will be in touch with you to make sure you complete your task on time and you refer enough people so that you will become, see, I want all of you, 100% of you to come to the next level. Okay, yes, it's not compulsory, but this is what I believe. I don't want you guys to leave this journey in 45 days. Okay, yes, so I believe you should basically receive this. Okay, yeah, Deepak ji, आपको आने वाले week में मिलेगा, because you have just taken admission last week, right? So you will receive the call. अच्छा, जिन लोगों ने last year में ये किया था, see what we have done is from April onwards, the people who have taken admission from April onwards, these are the people who are getting the calls right now. Okay, yes, once they are done, then we'll go for the people who have taken admission before that, because these people have a time limit. Okay, that is what is the priority for us, to make sure that they are completing their task on time and they are upgrading themselves as well. Okay, that is what we are basically tackling. My office schedule is a little hectic, difficult to manage work, class same day. Would it possible to have 1 day gap between classes? And so right now, Ashish ji, these sessions are not regular. This will happen once in a month. One session for green belt in a month, one session for the black belt in a month. Okay, apart from our regular Monday and Saturday sessions. Okay, and understand this, live sessions are not compulsory to attend. If you are very busy, just check the recording later. Focus on your course content, course number 1 and course number 2. These are the two major things. Focus on them. Live session आप जिंदगी भर अटेंड करो. Once you become lifetime member, जिंदगी भर lifetime अटेंड कर सकते हो. Okay, then you can check the recording lifetime. Are you understanding? There are lot of contents, lot of bonuses which are there. You know, there is library of more than 100 collection of books I have made for you. So all these things are waiting for you to come. First you complete your green and black belt, you become lifetime member, and then there are a lot of things which are there. Okay, yes. Are you, by the way, enjoying the live sessions as well as this hackathon, whatever efforts we all are taking collectively? Okay, including me and you as well. Okay, hats off to you, because you guys are working as well as you are staying here for additional couple of hours is not a joke. Okay, it's not a joke. Okay, so I can understand. I have seen this. So this is the commitment I want, to complete your courses in 45 days and help 2 people and become lifetime member and master black belt. Okay, that is what my wish is, and I wish you all the very best. So the people who want to go for the examination, send a message and we will arrange for you immediately. Okay, thank you very much. This is Dinesh Patil signing off. Keep learning, keep growing. Bye bye, take care. We will connect on Saturday with the live session once again. Okay, yes, and 20th को हमारा live session है, 20th को, right? So refer as many people as possible. Okay, 5, 10, 15, 20. Okay, last time one guy sent almost 40 people, पूरे department को भेज दिया था. Okay, lot of people got what you can say, a lot of people got themselves upgraded as well. Okay, so you can also do that. Send the invitation link. It is your personal invitation link. Just send it to as many people as possible. We can track now. Okay, the moment they click on your link, we can track immediately who have taken our course purchased. Okay, yes, super. Thank you very